Look around your room right now. Your phone, your laptop, maybe a smart speaker. You'd assume they're running cutting-edge chips from 2024 or 2025. You'd be wrong. Somewhere inside many of these devices is a circuit built in 1972, the 555 timer. Not as an antique, not as a collector's item, as an active, mass-produced component that's still rolling off factories worldwide. How many? Try billions. We're talking roughly 1,555 timers sold every single year. That's more than smartphones, more than any modern processor. A chip older than personal computers themselves. Older than the internet. Older than color television. Yet manufacturers, the smartest engineers on Earth, keep making it. Keep designing it into new products. Every single year. The question isn't why this chip exists. It's why we still can't live without it. Think about your microwave timer. Your electronic lock. That beeping smoke detector in your hallway. All could use fancy microprocessors. But here's the thing, they don't. They use the same chip from 1972. The 555 timer does one job perfectly. It makes timed pulses. One chip. 8 pins. Costs about 25 cents. Try building the same circuit from raw transistors? You'd need at least 15 separate components. More space. More cost. More points of failure. Manufacturers looked at this and thought, why redesign? We already have billions of these in the field. Everyone knows how to use it. We can undercut any replacement with price. The 555 became infrastructure. Replace it? You'd have to retool everything. Retrain engineers. Redesign millions of products. The switching cost isn't technical. It's economic. Perfection was never the real reason it survived. It was purely economic. Replacing it costs more than keeping it. Here's where it started. In 1972, a small company called Signetics faced a problem that needed solving fast. Customers wanted reliable timer circuits for their products. Hans Kommensend, an engineer working there, took on the challenge. His solution was brilliant in its simplicity. Just 8 pins. Just a handful of transistors inside. No unnecessary features. No bloated complexity. Pure, elegant functionality. The 555 did one thing perfectly. Measure and control electrical timing. And it did it far cheaper than every competitor on the market. Within months, other manufacturers wanted licenses to build it. Soon, everyone was manufacturing the 555. Signetics couldn't even keep up with all the demand. Even today, 50+ years later, companies make billions of them every year. The design never needed major revision. It was absolutely right from the start. Here's the secret. Hans Kommensend chose elegance over complexity. Just 25 transistors. That's it. Most engineers would add more, tweak more, complicate more. He didn't. The 555 uses precision comparators, simple analog circuits that compare voltages. No heavy-handed digital logic. No microprocessors. When you want something to do 10 different jobs, simplicity wins. It works as a timer, oscillator, pulse generator, or touch sensor. That versatility came from doing less, not more. 3 5K resistors, a couple capacitors, comparators measuring voltage thresholds. Brilliant minimalism. Every competitor tried to beat it. They added features, shrunk transistor counts, built versions with more control. None worked better. You can't improve perfection by complicating it. The design was clean and right. 50 years later, makers still reach for the original. Complexity ages badly. Simplicity lasts forever. Over 1,555 timers ship every single year. That's right, billion. One chip. Same design. Manufacturers still can't keep up with demand. It powers your kitchen timer. It's in your digital watch. Vibration motors in smartphones? A 555 timer controls those precise pulses. But it gets wilder. NASA uses them on spacecraft. Aerospace engineers specify them for satellites orbiting Earth right now. Why pick an ancient chip? Because it works flawlessly. It has worked since 1972. Here's the mind-bending part. Multiple electronics giants make billions annually selling this identical design. Philips, Analog Devices, Texas Instruments, all competing to manufacture the exact same circuit. Not a new version. Not an upgrade. A product so essential that entire corporations profit from making it unchanged. That's not competition. That's a monument to perfect engineering. The 555 didn't dominate because it was trendy. It dominated because it was right. Every algorithm gets faster. Every transistor gets smaller. But the elegance of solving one problem perfectly? That never goes out of style. You can build better things on top of it. You can't build better things by ignoring it. That's why engineers still reach for it today, not out of nostalgia, but necessity. A teenager building their first Arduino project. An aerospace engineer designing a satellite. Same chip, same logic. 52 years later, the 555 teaches us that good design isn't about being flashy. It's about being inevitable. About doing one thing so well that nothing else works better. That's the innovation that actually lasts.